Okay, thanks everyone for coming. It's great to see so many of you here. We're delighted today to have Dr. Órla Murphy, our head of department, and the reason many of us have jobs is thanks to Órla, who's going to speak to us today about inter- and trans-disciplinarity, the challenges and subjects that she really is properly expert on and can share her knowledge and experience with us. So I'm going to say any more. Órla, over to you.
Thank you very much. Thank you. Well, hi. It's really great to see everybody, genuinely really great to see everybody here and to be here in person, because yet again this year, as you all well know, we weren't sure what was going to happen. So it's wonderful to see you, right? And also just to get an opportunity to welcome you on behalf of all of us back here, and just to say as well that given the circumstances, we're really looking forward to seeing the work that you're going to do this year, really exciting year. And specifically, very conscious today, the first drafts of the final year projects are going in, so that's going to be great as well. Looking to see that, looking forward to that, and working with you on achieving all of your goals, you know, in terms of moving forward through this year and on to the next step. So this is the research colloquium. So this is very much my research, or the area that I'm interested in. So I'm going to give you a nice example of just one European project that I was in, and that's now finished. But if you like, this work has actually bled into other areas of my research life and work that I do, if you like, on behalf of the Irish research community in a European setting now. Okay? So one of the reasons Digital Humanities exists, if you like, is because of the need for inter- and trans-disciplinarity. So, for example, can you imagine if all of the computer scientists stayed in their own lane and only did, you know, computer science stuff? Or alternatively, if all of the sociologists stayed in their own lane, or the art historians, or the archaeologists, or the literature specialists, right? Imagine if all of those people only stayed in their disciplinary areas and did not move outside them or kind of engage or work outside them. You'd have very, very, arguably very rich and deep, but very distinct sets of knowledge production, if you like. So one of the challenges in the European research area over the last decade, and one that signals for further change and further challenge into the next decade and decades, is this area of inter- and trans-disciplinarity. So you know already, because you're in a university, that all of the disciplines and all of the colleges are very much set up around these areas, these disciplines or these subjects, and they're very, very distinct. And they have their own histories and they have their own identities. And people will say, I'm a chemist, or I'm a physicist, or, you know, I'm a literature specialist, or, you know, I'm a creative person, what have you. However, one of the challenges then is, how do we move forward, either as a research community or as a society, if we're all very tightly bound up in our own research areas and not moving outside them? So digital humanities actually is an area, as you know, that very definitely moves outside of the disciplinary silo and looks to engage with other people. So, for example, the degree that most of you are on is the first degree between two colleges in this university. So you have people from the College of Arts, Celtic Studies and Social Science working with computer scientists, with two, you know, very different structures and two very different ways of working. And even within the College of Arts, I'd argue that you probably have seen a difference between us in digital humanities and perhaps people in your second or your minor subject, you know, and that there are different approaches. So essentially what the European research area is challenging us all to be as researchers and as specialists is to foster and to harness and leverage a collaborative interdisciplinarity that's really challenging, right, to, as a person who's really expert in your own area, who maybe identifies as, I am, just say, a physicist, for example, to admit that maybe when it comes to working with somebody in another area that they know more than you, right? And how do you negotiate all of that? And some of you will have been on work experience last year, and you'll realise that very often that's just life now. You actually have to engage in teams, and everybody brings something to the table, and in order to get a project over the line, you all work together. So the quest is to harness and leverage collaborative interdisciplinarity, which is a key priority for the European research area's research and innovation policy. So when I'm talking about science here, I'm talking not just about kind of chemistry and, you know, explosions in the lab. I'm talking about the European understanding of science, which is Wissenschaft, and that means knowledge work or knowledge making. So everybody here is a scientist who is interested in knowledge work and meaning making. So science needs us, society needs us, research needs us to come up with quicker, effective solutions for very complex, grand challenges that are facing society at the moment. So for instance, a complex grand challenge, there was a brilliant one, obviously in the last while, which was COVID-19. So you had everybody from pharmacists through to public health specialists, through to digital visualization and data visualization specialists, all working together. So people who never thought about data visualization in their lives were all of a sudden looking at peaks and troughs and curves and mapping timelines and seeing and measuring who was being infected in what area and all of those things. So a complex grand challenge with analyses of complex systems that call for crossing departmental boundaries and interdisciplinarity to generate new knowledge of transformative power. Okay? So really interestingly in Ireland, you had an awful lot of experts on the telly, right? They didn't always all agree. So you'd have an epidemiologist maybe, you might have a public health specialist on, but then you'd have maybe a behavioural scientist who would explain why, even though things were opening up, people were still reticent to go across the threshold, you know, of their homes, depending on a number of personal or social circumstances. And all of this work is still ongoing to try and understand how people behaved and are behaving, and what we might learn from it, right, in terms of these big international surveys and analyses, in order to better predict what might happen if this happens again. Okay? And then to explore and exploit new types of problem-driven and user-oriented research and development research programs that go beyond well-established modes of targeted, incentivized research and development, which is very top-down. So you have two approaches in Europe. Sometimes they'll come out with a big, complex, grand challenge. They'll say things like, we have an aging population. What are we going to do about that, right? And put out a call and say, right, so we have 2 billion to fund that, and we want expert scientists from all and researchers from all over Europe to come in on that call. You'll have everybody from nurses to geriatricians to economists to psychologists, behaviour scientists, educationalists. You'll have a whole range of people coming together to answer that. However, what's been called for here as well is something that's bottom up, blue sky thinking. People who, because they work together, have realised, oh, hang on a second, we have an answer to a question here, right? Or they see that they have an answer to a particular problem. So this is what we call open innovation, innovation 2.0, open social innovation. There's a whole range of ways of describing that. And essentially what they're asking for is through interdisciplinarity and trans-disciplinarity to stimulate disruptive innovation to accelerate value creation and to scale up what they call the serendipity effect. Now the serendipity effect, you all know it. You're in a bar, right? In your previous existence you may have been in a bar, right? And you brush up against someone and realise, oh, hang on a second, we actually have, you know, similar interests, we might know similar people, we've pursued maybe different areas of interest or expertise, but, you know, from a completely different perspective, right? So serendipitous discovery, it's accidental. So to scale that up. You're not going to get the serendipity effect if everybody is in their own discipline, in their own corridor, just doing their own business all of the time. In order to scale up that serendipity effect, you have to encourage people to talk to each other and go beyond their own disciplinary area. And thus then, this is the final piece, to embark on and strengthen what they call translational research, to bridge the gap between what's happening in here, how are you doing, right, to bridge the gap between research communities, what's happening in here, and the real world, and impact in the real world. And what was really great for us in the university over the past year, and there's so many of kind of friends and colleagues from here, you'd see them on the 9 o'clock news, you'd be like, oh, that's Anne, oh, that's Declan, you know, whoever it was, because they're showing how the work that they're doing here is impactful in the real world, kind of in real domains. And to kickstart what they call an epistemic paradigm change. So anything to do with episteme or epistemology is to do with knowledge and knowledge making, yeah, and different forms of knowledge. And they're looking for that kind of shift in how we make knowledge, how we do science, that can only happen if we talk to each other, you know, and get outside our own silos. So, with that all in mind, this business of disciplinarity, what is it? So I remember I was very enthusiastic at the first class of the undergrad BA in Digital Humanities 5 or 6 years ago now, and I was chatting away about Digital Humanities, and one of my PhD students at the time came over to me afterwards and he said, Órla, he said, sure, people don't know what humanities are, not to mind to say digital humanities, or people didn't even realise what they were doing when they were coming into an arts degree, and that we needed to take a few steps back. So now that you're in a final year situation, most of you are in a postgrad situation, you understand, if you like, what a discipline is, because you've been in 1 or 2 or 3 over the last number of years. But then when I talk about inter or trans-disciplinarity, what do I mean? So there's all these different types of disciplinarities. There's intra-disciplinarity, multi-disciplinarity, cross-disciplinarity, interdisciplinarity, and trans-disciplinarity. And this man here has a lovely website, arj.no, and he's got nice definitions of each one of those, and I'm going to skip through them now, right? So intra is working within a discipline. That's what normally happens. Like, you honestly have people here who, if they're, I don't know, a historian of the 17th century, and they're working with a colleague 2 doors up who's a historian of the 18th century, they might think they're doing, you know, interdisciplinary work, whereas they're not. They're really working still within their discipline. They're working within the way they've been taught, you know, as historians, and they very much will do work in a similar way. Cross disciplines, right? So viewing one discipline from the perspective of another, but that's still very distant, okay? That's not getting into things too much. However, when it comes to multidisciplinary activity, you're kind of getting into it then. So people from different disciplines working together, each drawing on their disciplinary knowledge. So all of a sudden now you're in a team, there's a problem, right? And people are coming at it from multiple perspectives around the same table, and that working together is really important, right? Each drawing on their disciplinary knowledge. Each person having a contribution to make. Now it gets really interesting with interdisciplinarity, whereby now all of a sudden you're learning. You're integrating knowledge and methods from different disciplines, and there's a real synthesis of approaches. You realise that in order to get something over the line, that you're going to have to take a little bit maybe from, I don't know, the economist's approach, from the behavioural scientist's approach, that you need to understand what this guy, the climate specialist, the sustainability specialist, what he's bringing to the table if we're looking at, for example, opening up a new data centre, right? Everybody heard the news this morning, you know, potential electricity shortages, major energy supply issues. Data centres immediately named as a culprit in being a drain on national data centre, national electricity resources. Data centres the culprit. Okay, so you need a lot of people around the table then there, right? Because what are you going to do? You're going to say to Dell, to Apple, to Intel. Sorry about that, everybody. We're not going to have those thousands and thousands of jobs. That's not going to happen either, right? And similarly, every single person here, the very fact that we're broadcasting, somebody might be somewhere on a train watching this on a phone, that's all data center use, right? So that elaborate interconnectivity means that these are complex societal challenges and they need a lot of heads in order to be able to approach them. But then, if you like, the holy grail of the whole lot would be trans-disciplinarity, whereby you inhabit, if you like, the intellectual space. You kind of say, right, okay, I understand now how an economist, stepping into an economist's shoes, right, I really understand how they're approaching that. Okay, if I bring that together with my understanding of data and what's required, how can I move it forward? So again, all of those people around the table. So creating a unity of intellectual frameworks beyond these just simple disciplinary perspectives. Okay, so now he based that work on original work by Ziegler and Stember. And obviously it's not that easy or everybody would be doing it, right? So these are the problems, right? I mentioned earlier that an awful lot of research, not just in kind of science policy, kind of from a European perspective, but nationally, there's these top-down initiatives, right? We've got a problem. Aging population, that's a problem. Everybody focus on that problem, right? So they like doing that because it's not very risky, right? However, if a problem comes up, right, literally the one that came from left field, COVID is a great example. Imagine if, and you've seen it, that the people who actually laid the foundation for the vaccine had been doing that relatively unfunded and maybe even overlooked for years. And now all of a sudden they were centre stage and we were able to scale up the vaccine production because of that groundwork that had been done. Yeah? But that takes a very high investment in time and resources. If with that bubbling up, like those people, there was a very unclear set of outcomes. They didn't know that there was going to be the COVID challenge. It's risky, it's kind of fuzzy, it's not very clearly defined. It may lead to less efficiency because people aren't solution orientated. There's a little bit of wiggling around to try and get to an answer. There's challenges around common evaluation. So the way a physicist, an economist and a behavioural psychologist approach a problem from their separate disciplines and how they measure worth and value may be very different, right? And if someone's trying to get on and kind of progress in a job, that mightn't be great for them. And much higher risks for academic careers to be going out on a limb, rather than kind of following, everybody's doing bioscience, I have to do bioscience, right? But the rewards are huge. Now, he's very helpfully got a great, I think, visualization, the best visualization that I've seen of what all those things mean. Intra-disciplinary, very much on your own in your silo. Best of luck to you, right? Then multi-disciplinary, you're all in it together, but still very separate in terms of your thinking. The next one, eventually, you're actually touching up against each other. You're thinking, okay, we can learn from each other here. An awful lot of work happens here at the edges, at what we call like the interstices, at those parts where, we're tangentially involved, have an awareness, but could learn more, right, where there's a little bit of friction. Interdisciplinarity, where there's very clear overlaps, and then the trans-disciplinary piece at the very, very end, where you're actually inhabiting the intellectual space of the other person. You're willing to say, right, I have to move in order to understand what's happening, okay? So that's the best visualization that I've seen. So my example is, this is a project that I was involved in up to about 3 years ago, I would say. It's a TD stands for trans-domain, right? Because at a European level, major funders started to see that we needed to stop thinking, right, in very singular approaches, and this is a nice example. So I was a management committee member and a scientific committee member of the steering group, and I was, I had different roles in it. And most importantly, for my example, I was the convener of an international think tank series for early career investigators. So we had fabulous meetings with young people from all over Europe. Started in King's in London, we were in Belgrade, we were in Finland, we were, we were in Mainz in Germany. There was a few of them, right? And everybody together like this in a room thinking, right, so what are the issues of concern for you in this area? And we were very happy in our transdisciplinarity. I'll share the link to the slides in a minute if you want them, right? But essentially, there was a tremendous amount of people in the room from different areas. Lots of engineers, lots of physicists, people who were colour scientists, people who were interested in spectral relations, that's about light, people who were interested in spatial relations, people who were interested in geography, people who were interested in art history, people who were interested in all of these things. And they all worked, for the most part, they worked in the GLAM sector. That's galleries, libraries, archives and museums. However, a lot of them worked in industry, right? So they actually were either architects or cultural heritage specialists working to provide solutions. An awful lot of them were engineers producing devices for all of these people. Other people were, I suppose they were like CT scientists, very highly specialised. So in the example in the lab in Zagreb, on one trip that we were on, his job was to test a particular bolt for BMW, right? So he needed, with this particular scanner, to be able to see inside the bolt, teeny weeny bolt, now it's kind of barely the size of my nail, to make sure that it had integrity and nothing was going to happen with it, you know. So he was getting a lot of funding, obviously, from the private sector. Okay, so what we did was we just all got together to see what were the issues that were arising. And the single greatest challenge that we faced beyond language, because obviously not everybody spoke English, people spoke languages from all over Europe, and geographical distance, which was another big issue, or even finding the time where everybody could meet at the same time. The biggest challenge that we had was disciplinarity. Biggest challenge, because quite literally the language of all of the disciplines wasn't the same. When it came to the science, we weren't all speaking the same language, and we needed to try and define certain things. So an artifact for one person was an object in a museum. An artifact for another person, an engineer, was noise in a model that had to be eradicated, right? So even though everybody's level of English language was really, really high, there were still all of these little issues to tease out. And on a conceptual level, one of the biggest issues was even the concept of looking and seeing, right? So the art historians had a really, really high sense of visual literacy. Meanwhile, some of the engineers were like, what the hell is that? If you can't measure it, it doesn't exist, So there was a little bit of tension there. So we had a great time, if you like, trying to, explain ourselves to each other, and that took time. So, so there was different work groups. There was spectral object documentation, spatial object documentation, algorithms and procedures. One meeting in Italy, we started to write down all the different algorithms that pertained to lenses in all the different devices that were being used in all the different places to even scan or take images. Right? And before we knew where we were, one morning we were at 120, right? So we were trying to make things more transparent, but the more transparent they got, the more complex they got. And then you have to rethink yourself again. Analysis and restoration of CH surfaces and objects, and then visualization of CH here standing for cultural heritage, and their dissemination. So this one down here at the end, actually the last two down here at the end were very, very DH-y, because they were all about creating narratives or explaining what had happened, with the science and with the imagery. Okay, so what we came up with in the end over the course of the whole thing was a linked open data answer to the questions we were posing. no database that was in existence could actually handle that amount of variety and that amount of variables. So what was created in the end is what we call a knowledge representation model, and you'll know that as a knowledge graph. Those spaghetti monsters, right, where things break out of an SQL database and all of a sudden are much more organic in that they can grow, right? But they're also very bottom up in that you kind of create them from scratch. So what the project did was it created its own knowledge model from scratch. So it's a very semantic solution using the semantic web, and essentially it was the usual. None of this is unusual, right? It used web ontology language OWL, and we just defined our own ontology. What do I mean by ontology? It's kind of the set of words that we use to describe our world. So now, instead of having, remember the fright of the potentially 1.5 million algorithms that we were going to have to notice, we decided we were going to define the world. This is the definition of our world here. And within that, we can be as granular as we like, but we have to put some limits on it. So it's a very semantic solution. So what we used was, and you can have a look at it there yourselves. It's out of Stanford. It's a tool called Protégé, and you can use it to build your own knowledge model and your own knowledge graphs. You define all of your own items, your own classes, your resources in there, and that's what we did. So for the early career investigators, for all those early kind of career people who were master's students, PhD students, postdocs, some people who had just started in academic jobs, some people weren't in academia at all, as I said, they were working in industry. Other people were some policy people that were really interested in how they were going to integrate all of this stuff together as well. So our focus was on the vocabulary, because we said, right, this is something that we can actively contribute to. So we created a giant Google Doc, right, that we all had access to, and we began together, so we could do this outside of the meetings, we began to highlight certain terms that we all needed to understand. So the first word there is absorption, the next word down there is accuracy, right? So there was murder about a definition of accuracy, as you could imagine, right? There was it's very exciting times. Okay, and further down, artifact there, that was another one, right? Algorithm, registration, alignment, all of those things. So it really worked very well, because it meant all of a sudden we had a common kind of, a common agreed set of things that we were going to try and do, and that worked out together. So there it is, there's Protégé, have a look at it there now. As a student, you'll have access to a free version. So then it was all about liaising with colleagues online to populate the ontology. Ontology, it's a bit like a controlled vocabulary. So you define your world and you say, right, so these are all of the things that we need to define, and then you decide what the definitions are going to be. So, and in a knowledge model or a knowledge graph, you're not just defining the objects or kind of particular nodes, you're also defining the relationships. So now, unlike a standard database where a person, let's say Órla Murphy, is an employee, has an employee number, has an address, right, and I'm just one field, all of a sudden now I am a number of other things, right, and I am both the subject, right, of the relationship, and I'm the object of the relationship. So I'm a daughter of, but I'm also a mother of, okay? So it's very complex and time consuming, but really, really interesting and yields good results at the end. So, right, so there was further definitions. Then there's a lovely platform called the Open Science Framework, OSF, and we were working away in that as well. But specifically, there was another chapter. There was a full book, but this particular part was a chapter in a book, and there was lots of Horizon 2020 applications came out of it. So further applications or further funding for further work. So the industry people were getting resourced to do things that they wanted to do to develop their products. They were also liaising directly with customers, right? So many of the big museums like the Louvre and the Prado and the national museums in Belgium, and I think at time can't remember about the Netherlands whether or not they were involved, were all part of it as well. So there was a really good cross-section of community, you know, both users and, if you like, designers all together. Thank you for listening. I'm going to pop up the book. It's here in Google. The book that came out of it is here in Google. It says Digital Techniques for Documenting and Preserving Cultural Heritage. The one chapter that I contributed to is here, right? And you can have a look at that. It's about exactly this type of thing. Key terms, basic concepts in terms for measurement, all of that kind of stuff. But then there's some other lovely things as well in here as well for those of you that like a picture. So my colleague Despina and her team, from an archaeological perspective, using 3D to bring things together. So this was found in tatters all across the field, and they managed to bring it together. So that's a nice example. So in terms of an end product, this is what happens. So instead of something in multiple shards all over a field, no idea what any of it is, most of us would just have discarded it. You get something that's brought back together and colorized. There's another chapter in there as well that's really, really interesting in that it takes all of the different techniques and it uses all of the different techniques back down on top of one simple coin, and it shows you, the differences between all of the different techniques. So each one of them will say, oh yeah, I'm going to give you an accurate measurement and an accurate representation of this, right? But then when you look at them, they're actually all completely different. And you wouldn't see that if you didn't see them kind of compared and contrasted alongside each other, okay? So that's just a small example of a small project. So this was part of a bigger initiative called Cooperation in Science and Technology. And they're a major funder. They fund about 40 million euros worth of projects every year. So now I've taken this idea about inter and trans-disciplinarity, and I'm working with colleagues from across Europe to define it within their funding call so that people kind of understand more clearly what we mean when we say inter and trans-disciplinarity and how we reward it in these bottom-up project proposals so that it's easier for people to get the grant funding for what it is they want to do. Okay? So thanks everyone. Any questions? Or are you flattened by that? Was that too quick?
Thanks. Oh, that was fantastic. Really brilliant explanation of the differences too.
The differences,
inter and intra and multi and trans and all that.
So people use them interchangeably, but they're not very interchangeable. Yeah.
No, they mean different things, but they often are used as though they're synonymous and they're not.
Yeah.
I have a question actually, if that's okay. About language. I was struck when you said about accuracy. Because I can imagine trying to define accuracy with science. I research project I'm doing, the problem word I came across was attribute.
Oh, word.
I did the attribute wrongly in a science perspective, and had to, and was actually was scolded at one point when using it that way.
That's right. Yeah.
I was wondering how long, like these issues of common language, and you weren't just dealing with different. You were dealing with different languages as well.
Correct.
European language. Like, was this did this conversation run through the entire project, or did you get it resolved and then you re-terminology?
And what was really interesting, right, was the man who led the project, Professor Frank Books from the University of Mainz. He's an engineer, right, and he's big into, I suppose, so he's coming from an engineering perspective where everything has to be measured, and unless it can be measured, it's not there. So he then went to his kind of spectral colleagues. Right, remember the different work groups that I mentioned, spectral and spatial and algorithms, right? So he went out to his, what you call more science colleagues with this idea about the knowledge representation model. And he got most resistance there.
Oh, right.
Because their definition was their definition, and it was bounded and sacrosanct and you can't actually touch it. Meanwhile, he thought he'd have most trouble bringing it to what we call the more arts side of things, arts humanities. You know, the visualization, narrative people, the art historians, the conservators.
Whereas the languages are kind of raw data.
Yeah, right. Yeah. So meanwhile, we all went, we appreciate that language can be fluid and that you need to actually tease out what exactly is going on, and it's not just my way or the highway, because we were more used to that kind of thing. So it was really interesting. So he was so grateful in the end. It was a meeting in Spain, actually. It was in Valencia in Spain. And he had been in a meeting in Amsterdam the week before, and he came out of it and he, I think, was relatively depressed, right out of his mind, right? Because, he was hoping for this kind of shared agreement and it hadn't happened. And then, he came to us and he was like, hope,
But how did you get to the point of the agreement?
Years, right? So discussion, trust, teasing it out. I would say there was about 2 years of that, and there was low points and there was high points. Now obviously we're not all working together all of the time. So this is extra over on top of your day job, and it was the same for them. So you might have 2.5 days twice a year, right? And then you have the Google Doc afterwards and toing and froing and that kind of thing, So that was it. So we used to have 2 big meetings, and even at that, within the context of the 2.5 days, there'd only been intense 4 or 5 hours, even though the breakthrough came in Belgrade. I remember I forgot that in Belgrade they didn't use, they don't use our alphabet in the old town, they use Cyrillic, So I got dropped there and I was arriving a little bit late because of things, right? And they were warning me that there was going to be drama because there was 2 rival teams having a massive basketball match, right? And it could be dodgy, And I was trying to get in and out early, and I popped out of the taxi, and I honestly hadn't a clue where I was because I couldn't read any of the signs. But that night we stayed, so I got there, I don't know, it was probably about 5:30. We stayed until maybe 2 in the morning, and we hammered a lot out that night. And we were sending out like for food, and there was different people going on. There was one kiosk in the end that someone brought back a load of Twixes. I remember that, So that's the reality of it, but it just takes time. But everybody was happy to stay there because we all knew it needed to be done, So that's it. So it's not a kind of an instant thing, it's an
process.
Process, yeah, 100%. Thanks for that, Teresa. Any other thoughts? No? Okay. So, right, I'm not sure who's next week.
Next week is Kieran Wallace from the Beyond 2022 project in Trinity in Dublin, which is actually a really exciting project about trying to recreate the lost 4 courts archive that was blown up in 1922. So they are for that.
And there's a huge visualization aspect to that. So obviously there's the pure information science piece, where they're taking the scanned documents from all of the different locations across the British Empire all over the world. But they're then also having a beautiful visualization done, I think, by NOHO, Nilo Hashim's company, whereby you can actually, in a virtual world, walk through the stacks and